You should take notes on each of the problems in this video as we discuss the different types of arithmetic that you might be asked to do with matrices. So adding and subtracting, we have to have like matrices, the same number of rows and columns. We call that the order of the matrix. And we're just going to add the similar positions. Scalar multiplication really just means distribute by a constant. So the word scalar and constant are synonyms. And matrix multiplication will be a little more complicated. We'll do kind of a weird distribution where we'll take every horizontal row times the elements of each vertical column. So you'll see that better as we do some examples. So in our first example, and again, make sure that you take these down in your notes so you'll have them when you start doing the homework. Here we are subtracting two matrices, and remember how we describe the order. We take the number of rows times the number of columns. So this is a 2 by 3 matrix, and likewise this matrix has 2 rows and 3 columns. So to subtract, we simply take the elements in similar positions. So we're going to take the 3 minus the 8, and then we go to the next position and we'll take the negative 5 minus a negative 6. Remember, we're subtracting, so we'll have a negative 5 plus 6. And then we'll have a 1 minus a 3. And then we're ready to go to our next row. So we have a 0 minus a 4. And then we have a negative 2 minus a negative 1/2. So this becomes adding a 1/2. So we'll have a negative 3/2 or a negative 1.5. And the only purpose of putting in a couple of fractions and decimals here is to remind you that the elements could be any kind of numbers. So we have a 7 minus a 0.4. So we would have a 6.6. And my negative 2 kind of moved up there. So we have a answer that turned out to, and my tablet is being fussy here. 1 minus 3 disappeared. That was the minus 2. And then we have a 0 minus 4, which I lost here. All right, so we had 2 by 2, or 2 by 3s, and when we added them together, notice our result was a 2 by 3. All right, let's try some combination here of scalar multiplication. So this is simply like distributive property. So 2 is our scalar or constant. So we could multiply each of these terms by 2, and you might choose to do this all in one step once you've got the idea. But we distribute the 2, we multiply it times each term. And then in our second, we were multiplying each term by 3. And then because they are like sizes, these are 2 by 2, so we could call them square matrices if they have the same number of rows and columns. But because they have the same order, 2 by 2, we can add the similar positions together. So the 8 plus the 0, the 4 plus the 3, the negative 2 and the 12, and the negative 4 and negative 9. So we did scalar multiplication first, and then we did matrix addition. All right, now we're ready to see what it's like if we are multiplying two matrices together. And our first matrix A is a square matrix, 2 rows and 2 columns. So we say it's a 2 by 2. And matrix B is 2 rows and 3 columns. So what's important for matrix multiplication is that the number in the middle here has to match, because now you'll see that when we're asked to find AB, that simply means matrix A times matrix B. When we're asked to multiply, we're going to take this horizontal row and we're going to pair it up term by term with the column, and then we're going to add up the results. So I'll show you what I'm doing for the first one. We're going to take the 4 in the first position times the 5, and then we're going to take the 2 in the second position times the negative 1. So we'll have a 20 plus a negative 2. So our first result will be an 18. And then we're going to do that for every row times every column. So again, I'll repeat a little bit more at first, but once you get the hang of this, you'll do it very quickly. So now, like distributive property, now we have to take every row times every column. So now I'm going to take the first row and the second column, and I'm going to do the same thing. I'm going to pair up the 4 with the 10, and I'm going to pair up the 2 with the 3. So we'll have a 40 plus 6, and we're in the first row, second column. So we were multiplying the first row and the second column, and that's where I put my answer, in the first row of our answer in the second column position. All right, let me erase some of my markings. And now we still have one more to go here because we're going to take every horizontal row times every vertical column. So now I'm still going to take the first row, but now I have to multiply times the third column. So you probably already saw the pattern, so we're going to match the 4 with the 0 and the 2 with the negative 2. So we have a 0 plus a negative 4. And that was our first row times our third column. So that's where I put it in my answer. I put it in the first row, third column. And now you can see that we've taken the first row, 4 and 2 elements, and multiplied times every column possible. So now we're done with that row, and now we're ready to move on. So now we're going to take our second row and do the same thing. We're going to pair it up. And let's see if I can just quickly talk through this. So I pair up the negative 1 with the 5. So we'll have a negative 5 and the negative 2 times the negative 1. So negative 1 times 5 and negative 2 times negative 1. And then we're just adding up our answer. So we've got a negative 5 and a positive 2. So negative 3. And you'll excuse me if while I'm talking and recording here, if I make an arithmetic mistake, you can correct that for me. And now we're ready to take our second row times our second column. So we're matching the negative 1 with the 10 and the negative 2 with the 3. So we've got a negative 10 and a negative 6. So we've got our second row, second column. So notice where I'm putting it. I'm putting the answer in the second row, second column. So I had a negative 16. And then we've got one more to go, one more combination, the second row times the third column. So I'll erase again my previous work so you can see what we're doing currently. So we're taking the negative 1 times the 0, and we're taking the negative 2 times the negative 2. So we'll have a 0 plus a 4. And since we were multiplying the second row times the third column, our answer was put in the second row, third column. So now let's clarify. We took a 2 by 2 matrix and we multiplied by a 2 by 3. Remember, it's always rows by columns. So our second matrix had 2 rows and 3 columns. So these two must match. You have to be able to match them up horizontally and vertically. So we have to have the same number of columns in the first matrix matching with the number of rows in the second matrix. So those two must match. And then look at what we ended up with. We ended up with a 2 by 3. So this is the result. So the resulting matrix ended up to have, spell that correctly, the resulting matrix ended up to have 2 rows and 3 columns. So let's talk about this a little bit more. If we had a 1 by 3, so here's an example of a 1 row, 3 columns, and in fact we will call this a row matrix since it only has 1 row. So we could call a row matrix something that has one singular row. It just looks horizontal. But its order would be a 1 by 3. And our second matrix here has 3 rows and 4 columns. So remember that these two must match. So these two inside terms must match, and then this will be our result. So our resulting matrix will be a 1 by 4. So we would simply take this horizontal, these 3 horizontal terms, and match them up vertically, and we'd have to do that 4 times. So if I try to quickly do that work, I will have a -3 matching with a -5, and then we like the 0 term because that middle term will always be a 0, and then we're going to match the 2 with the 4. So we've got a -15 and a +8, so I end up with a -7. And notice where I'm going to put that. I have row 1 times column 1. And now I'm ready to do row 1 times column 2. So I'll rewrite the terms here. So we'll have the -3 pairing up with the 2. The 0 pairs up with the -3. And the 2 pairs up with the -1. And you probably already have the pattern here. So we've got a -6 and a -2. And we're doing first row times second column, so we move over to the second column, and we had a -6 and a -2, so we have a -8, and let's press on. First row times third column, -3 times 1, plus a 0 times a 5, plus a 2 times a -2, so we've got a -3 and a -4. And one more time, we take each term of our row times the fourth column. So -3 pairs up with the 10, the 0 with the 4, and the 2 times the 5. So we've got a -30 and a +10, so we have -20. So again, look at what happened here. We took this 1 by 3, and we were multiplying it by a 3 by 4. These terms had to match, otherwise we wouldn't have been able to do our weird distributive property, and our result ended up being a 1 by 4. 1 row, 4 columns for our final answer. All right, so we're almost finished here. So could we multiply a 3 by 2 times a 4 by 2? Nope, because these terms do not match. So we wouldn't be able to do that matching going across and down. So no answer. You would not be able to multiply. So you might say, well, what if I reversed them? What if I turned this around by commutative property? What if I took the 4 by 2 first and then multiplied by the 3 by 2? So excellent point. You can already see that matrix multiplication sometimes might, here it wouldn't work anyway because these two terms still don't match, but you can see that matrix multiplication is not going to be commutative because reversing the order, sometimes it might work. All right, so one last question here. Can we multiply a 2 by 1? Remember what a 2 by 1 would look like? A 2 by 1 would look like 2 rows but only 1 column. Could we multiply that by a 1 by 5? That would look like a 1 row but 5 columns. So can you see that we wouldn't be able to pair up vertically and horizontally? So if we, and I wrote this one wrong, a 2 by 1. This one we would be able to pair up. 2 by 1, sorry, I'm misspeaking here. Yes, these do match. So what would this amount to if I was multiplying these two examples? Well, my distributive property is just very quick. First I'd take the 5 times the 3, and then I would take the 5 times the 5, and then I would take the 5 times this 3. So then I would take the 5 times the negative 2 and the 5 times the 0. And then I'm ready to move down and take the second row and match it up. So the 3 times the 3. So now I'm in the second row and the first column, and then the second row times the second column, and then the second row and the third column, second row and the fourth column, and second row and the fifth column. So yes, we took a 2 by 1 times a 1 by 5, and our result turns out to be a 2 by 5. The result will be a 2 by 5, and right there it is, already done for us. All right, let's see how you do with that work, and we can discuss any remaining questions when we get back to class.